All right, so here in this next question from 82 to 87, we have 150 students from your college that was asked if they passed last year's final. 100 students said they passed. So the first thing we have to do is calculate p hat. P hat is x over n. So I got x is the number of successes over the number of people, sample size. So here's x and here's n. When we divide that, we get 2/3, which is 0.67. To calculate the standard error, remember that is the square root of p times 1 minus p divided by n. So we just go ahead and put that in our calculator, and we get the standard error to be 0.0384. Now, like I said, it's good practice when you're kind of rounding in the middle of calculations to use the 4 decimal places in the next computation. So I go ahead, instead of doing 0.04, I do the 0.0384. So you might want to do a similar method on your final. Now it says calculate the 95% confidence interval. So 95 says that z sub c, or z critical, is going to be that 1.96. Okay, you can see that right here. All right, so z critical times, so you basically, all these are the same layout, right? You have some, let me just make this smaller. You have some test statistic, or some statistic, plus or minus some error, right? And that error is broken into the, use a little pen here. The error is broken into the critical value for the confidence interval, for the confidence, and some standard error. So with p hat, remember the standard error is square root of p times 1 minus p over n. Okay. So what we get is our 0.67, which was our statistic, and then to get the lower bound, we do minus 1.96 times that standard error. Now notice, I didn't round this off. I did it all in one. So if you do rounding, you are going to get different answers. Again, if 0.63 was the answer in Blackboard, I would include 0.62 and 0.64. But if you're too far off in your rounding, you're not going to get close. So do it the similar way I've done it right here. All right, then it said to find the upper bound, and again, instead of you're going to have p hat. Looks like I could actually write p hat now. So you can do p hat plus an error, margin of error, and that error again is z critical, which was 1.96 times the standard error. Oof, it's hard to write. Okay. As you plug all that in, you get your upper bound to be 0.71. It says last year 70% actually passed. If we did a simple random sample of 121 grades from this year's test, 66 had passed. Is there significance to show that the proportion of passing students has decreased? So again, we need to set up our null hypothesis and our alternate hypothesis. Okay, so it says 70 last year 70% actually passed. So that's p equals 0.70, and then here it says, is there evidence to show the portion of students has decreased? So that means we're going to try to see if there's evidence to support that it's less than 0.70. Okay. So always, all right, so the first thing we have to do is interpret that the 70% is actually our p-value, right? N is 121. And this year it says 66 had passed. So that's kind of like our, that's our p hat. All right, so here in this formula, I guess I'll write it out here. we have Z equals P hat minus P divided by the standard error, which is the square root of P times 1 minus P over N. Okay. So let's take note that P hat was 0.66 and we're minusing P. All right, so that's the null hypothesis because that's what we know they've actually passed. Now, when we do the test statistic, the thing to remember is we use P here, not P hat, and 1 minus P. So we'll go ahead and, sometimes they call this P naught, right, for the null hypothesis. So this would be P naught and 1 minus P naught. Okay, so that's important to remember. And then when we calculate that, we get a Z statistic of negative 1.96. So let's see what we do with that. So first thing it says is what type of test are we conducting? And if we go back to our alternate hypothesis, use a different color, you can see this is less than. So this is going to be a left tail test. Okay, and this right here is our p-value. All right, so that wants to calculate that p-value. Oops. Let's see, let's use black. Okay. So this was negative 0.96. So our p-value is a probability that it's less than that. Okay. So we'll go in negative bound. We're using negative 100. That should be sufficient enough. Upper bound, we use our 0.96. When we calculate that, we get 0.17. That means this area right here is 0.17. We need to compare that to an alpha, right? So let's see. Is there evidence to support the proportion is less? This year at a level of 95%. So actually it's the confidence of 95%, which would be correspond to a significance of 5%. Okay, so I'll have to slight variation. So so alpha equals 0.05, and notice that the p-value is greater than that. So therefore, we would fail to reject the HO. And if we look back, if we fail to reject this, that means we are accepting it, so to say. And we are not supporting that it's less than. Okay, so there's not evidence to support the proportion is less this year. Okay, I believe that's the last one. Hope that was helpful.